Hi, everyone. I'm really glad that you're here with us today. Welcome to our webinar, AI and Scholarly Research. I'm Leah Hines, the Executive Director of the Charleston Conference, and I'm really happy to be joined by a great group of people today. But before we get to the presentation, I'm going to go through just a few housekeeping notes here about the webinar. So when you join, you should have seen a screen that asks how do you connect with your audio, so you can set it up with computer audio is what we recommend. If you're having some issues with hearing, you can try going through phone audio, but you're going to get the best quality experience using your computer speaker system. At the bottom of your screen, you'll see there's a little icon that says raise hand. If you click it, it's green, and then you click it again to lower your hand if you have an issue or a question. Sometimes the best way to do that, though, is to actually use this attendee chat right here on the left. If you're having some problems hearing, you can send a message directly to me, and I'll try to take care of that as soon as I can. We are going to hold questions till the end of the presentation. There's a button on the right that says Q&A, so you can click that. It'll pop up. You can type in the text of your question as it comes to mind while the presentation is going on, and then we'll hold that till the end. And Matthew Ismail, who is our moderator, is going to help go through those questions at the end. There's also some options for original size, full screen up at the top there. And with that, as I mentioned, Matthew Ismail is going to be today's moderator. Matthew is the Director of Collection Development at Central Michigan University, and I thank him very much for being here and helping us with this today. With that, I'll turn it over to him for introductions. So thank you, Matthew.
Thanks, Leah. Well, as Leah said, the topic for the webinar today is artificial intelligence in scholarly research. The speakers today are Ruth Pickering and Haris Dindo from Yewno, a technology company whose Yewno Discover platform, quote, helps researchers, students, and educators to deeply explore knowledge across interdisciplinary fields, sparking new ideas and revealing unexpected connections along the way, end quote. And the speakers today are Ruth Pickering, who is the Yewno co-founder and chief operational officer and strategy officer. Haris Dindo is Yewno's chief data scientist. And Jason Chabak is the vice president for business development, who I do believe has just arrived. And so I'll allow Ruth and Haris to introduce themselves if they wish, and turn it over to you.
And Matthew, before we get started with Ruth and Haris's presentation, I forgot a step in my introduction. So I have a couple of poll questions for everyone that I am sorry that I forgot to do first. So if you could just take a few moments to answer these questions, let us know what type of attendee you are. If you're an academic librarian, a medical librarian, special, public, publisher, vendor, consultant, and if it's something else that's not on here, let us know in that attendee chat what that other option might be. You can also use the attendee chat to take a moment to say hello, give us your name, where you're from, say hi to other attendees that you may see their names, that you know them. Use the attendee chat for just a moment for that. The second question on the poll is, which of the following is most true for your institution? We already use AI in our library. We are about to use AI. We're evaluating our options. I do not expect AI to play any role in our library, or I'm not sure what qualifies as AI. So I'll give you a moment to answer those questions. So far, it looks like, I'll put the answers up in just a moment, but we've got about 68, 69% academic librarians, a few publishers and vendors, and the majority of people are saying we are evaluating our options for use of AI. So answers are slowing down. There's a few still coming in here. Let me give that just a moment. And okay, I think that's it. I don't see any more answers coming in. So I'm going to end that question. So you should be able to see the results. We ended up with around 66% academic librarians, 3% medical, 8% special, 19% publisher vendor. And then for the AI question, 53% say we're evaluating our options, and the second most common answer was, I'm not sure what qualifies as AR or AI, so 31%. Now I have a second question. Let's see here. Let me go to my second question here. And that's this first one. There, let's try it again. AI, do you use AI in your professional life? And do you use AI in your personal life? So we're curious about those two options there. Professional versus personal. So far, overwhelmingly, people are saying no, they do not use AI in their professional life. 93% so far, 94%. And it's a little more evenly split for do you use AI in your personal life. Right now it's around 36% yes, 64% no for personal. So I'll give that for just a few more moments. Go ahead and click your answer for that, and I'll end polling and turn things over to Ruth.
Thank you very much, Leah and Matthew, for that great introduction.
Yes, thank you. So there we go. We have 92% said no for AI in their professional life, and then it was split 40-60 for do you use AI in your personal life. So thank you, and I'm going to turn it over to Ruth and mute myself now.
So welcome everybody, and thank you very much for joining this webinar today. First of all, what we're going to look at is really a bigger picture overview of artificial intelligence. What is the term all about? What does it mean? Then specifically relating to today's webinar, looking at AI in scholarly research and whereabouts can it help? As part of that, we're going to talk about knowledge graphs, which are a critical component. And we're going to cover some technical information about how AI-based concept search differs from traditional keyword searching. Then we're going to come on to more task-specific AI and general AI. And then we're going to have a little bit of a look at the market. From the poll we've just taken, it doesn't look like many people are actually using AI today. So we're going to see about how we think the market will change and what sort of timeframes that will happen in. So first of all, what is artificial intelligence? So artificial intelligence is a very big term. It's like saying medicine or engineering. If you work in medicine, you could be a cognitive neuroscientist, you could be a gynecologist, you could be a nurse. They're three very different roles, very different jobs, very different knowledge bases. Equally, if you say something like engineering, you could be an electrical engineer or a civil engineer, completely different things. So as we look at this word cloud about AI, you can see a lot of terms which are very often associated with AI. And these things are completely legitimate. So you could see somebody who's working in natural language processing and they could call themselves an AI company. You could see somebody working with speech recognition and they could also call themselves an AI company. And like many people on this call, if you went to conferences about 5 years ago, you probably wouldn't have seen much of a mention about AI. And maybe 3 to 4 years ago, you'd have seen a few people talking a little bit about AI. And over the past couple of years, more and more people at conferences and vendors will position themselves as AI providers. And they can legitimately do so if they have any element that you see in front of you as part of their product. So I think the critical thing here is that AI is expected to be the main driver of productivity and economic growth for at least the next 20 years. And that is a statistic from the Davos panel in 2016. So I think we're all aware, whether we're using it today or not, it's going to be a major driver in the next few years. So what is the problem we're trying to solve in terms of scholarly research? So one of the main problems is simply the overwhelming volume of information and literature that is available and that increases every day. So we all know that what we're looking at is out there somewhere, but do people know the right place to go? Do they know how to formulate the best search query? And are they able to distinguish between all of the types of information and content available in terms of which source is the most reputable or the best? So One of the things we're going to talk about today a lot is how AI can help overcome partly the fragmentation of content and as it exists today, and partly also help people find what they're looking for. So I'm going to give a brief overview end-to-end of how artificial intelligence can help people find what they're looking for in this bigger picture in terms of taking unstructured data and turning it into a knowledge graph. And then I'm going to hand over to Haris Dindo, who is the Chief Data Scientist, to talk through some of the components and the technical side of AI and how things really work. So what you can see in this picture on the left-hand side is you can see huge volumes of unstructured text. So this could be a patent, a journal article, a book chapter, a piece of news, a dissertation, any unstructured text. And huge amounts of unstructured text can be ingested and kept up to date as often as things are published, whether that's every day, whether that's in 5 or 10 minute slots for news. And then what you see happening in the middle of this picture is a series of algorithms who are reading the full text. And what they're trying to do is to read text like the human brain reads text. So they're trying to recreate a neural network model. So not only are they scanning the text and hunting for keywords, they're actually understanding the context and the meaning. And then what happens is, as the machines understand meaning in the form of concepts, they promote those into a multidimensional graph network. And on the right-hand side, you can see this enormous multidimensional graph. And there's nothing new about graphs. They've been around for 250 years. But in recent years, the technology has evolved. And we're going to talk through that in the next few slides. And the great thing about any kind of graph network is it's a fantastically flexible environment. So any different user can use it to interrogate any different subject that they're interested in to any level of detail. Because within the graph, all of the concepts carry pertinence scores, and all of the relationships between concepts can be linked back to the source literature. So any connection can be explained. So that's a very, very high level picture of AI end-to-end and how it can be applied in the scholarly research world. And I'm going to hand over now to Haris Dindo, the Chief Data Scientist, to start talking through a little bit more of some of the details behind the technology. Haris, over to you.
Thank you very much, Ruth. Excellent introduction. So yes, we have been working at Yewno over the past years in really introducing AI into the world of scholarly research. And as Ruth just mentioned, we're really continuously processing extremely huge volumes of unstructured data, extracting knowledge out of this data, and we will shortly define what knowledge really means in our world, and connecting pieces of knowledge together in this huge graph that we call knowledge graph, that then our users and our final users can really interrogate and find answers to their questions. To be able to do this, we have been adopting different techniques from the AI, and AI is a very broad term, as Ruth mentioned. So AI really encompasses different fields of studies, but over the years they actually started being independent one from each other. So we'll be talking here about three main components of our technology that are giving the final results that you will see very shortly. So in the first place, this is AI, more classical form of reasoning, knowledge engineering, and knowledge representation. Computational linguistics use really to understand text, understand unstructured data, and extract meaning out of it. And machine learning, which is a set of techniques that go from deep learning to more statistical type of learning, that really then help machines learn by looking at data and by looking at patterns and examples, learn by themselves and learn to relay this knowledge into this huge knowledge graph that we have been talking about. So these are really the three main components, and we're going to see how these three components really are playing together and are coming together in a coherent way to build our final technology. If we go to the next slide, please, you will hear throughout this presentation very often the word concept. So we're really working along this idea of conceptualization of information to produce knowledge. So instead of classical NLP-based approach, NLP stands for natural language processing, or classical keyword-based search that we all are used to, we are working with concepts. And we will see that a concept has a very, very special place in our technology, and everything really rotates around concept. And we call concepts an atomic units of knowledge, because the whole knowledge that we can extract from whatever data source can be represented as really a network, as a mesh of these interconnected concepts. So concept really is just an idea. It's a notion, and you will see that in our product, a concept can be a typical entity. It can be a person, it can be a place, it can be the name of a company, but it can be something more abstract. It can be machine learning itself as a concept, AI itself as a concept, publishing is a concept. So everything that we can as humans conceptualize, and we as humans can relate to by using our own language, can be represented as a concept. Of course, what is important about these concepts? It's important to extract significant concepts, and it's important to extract relationships that are significant between these concepts. Ruth already anticipated this. We use a number of measures to tell our systems and our users how important concepts are within a specific piece of within a specific document, or how important relationship between these concepts are. And once we have these relationships in place, we can really start thinking of inferences. Inferencing means extracting a new knowledge out of existing knowledge. So you will see that by looking at our graph, by looking at our connections, you can really start postulating certain hypotheses, and you can really go over, expand our graph to search for answers to your hypothesis. And AI will help you in actually reaching these conclusions. And next slide, please. So let's really quickly go back to concepts, and just for us to understand what is a concept and how this is really important in the context of semantic search in general, but scholarly search and research in general. So concepts are not keywords, and why we stress this this concept is because if you look at keywords, you will be quickly overwhelmed by a number of different meanings that a single word can have. So in this example, think of Jaguar. Let's say that you have a library of 200 million or 300 million or however big number of items, and you want to search for all documents containing, in some respect, the concept Jaguar. So you as a human in your mind, you will be thinking of Jaguar as either, let's say, a cat or an animal, or as a car or something else. But for the machine and for the classical keyword-based search, if you enter Jaguar, it will just return you all the documents having that specific keyword without any potential disambiguation in your documents. So you will not be able to have all the documents containing Jaguar intended as an animal, but you will be returned a huge amount of documents which just have that word in them. So this is why concepts are important, because concepts are keywords, and you will see different keywords that really carry a meaning. We're simplifying here because actually in our technology, we do not care really that much about keywords. A concept can also be a sentence, or can be a very complicated set of words. But this is just for you to grasp an idea. So, for example, we can think of quantitative easing as another potential concept. Global warming is a concept. Whatever really you have in your mind will be a concept. And at Yewno, we have 5+ million concepts. So whatever you can think of, really, you can be able to search using our technology. If you go to the next slide, we will see that I think we skipped one. Exactly. So how we then, as Yewno, understand the difference between Jaguar intended as animal and Jaguar intended as car, for example, in this specific example. Every single concept has a definition, has a piece of text that will describe what that concept is all about. It helps humans, it helps us when we search for a Jaguar, understanding that this is the exact concept that we're looking for, this is the exact entity, this is the exact meaning that we're looking for. But we will see that it also helps the machine to build a semantic representation of that concept. Because if we have text that describes a specific concept, we can then adopt the techniques that we introduced at the beginning, specifically computational linguistics and machine learning, to build more advanced representations that are called embeddings of these concepts into a semantic space, which is a mathematical abstraction and representation of really a semantic, of certain semantic properties. We'll come to that in a couple of slides. Together with the definition, our concepts also have topics. That's another distinctive feature, so that we can really understand, and these topics are, again, completely autonomously generated by our AI, but by our technology, and we attach to every single concept a set of labels which describe, which categorize these concepts according to our internal taxonomy. And the same we can do for every single concept that we have in our system. And if we don't have a concept, I think the next slide will go over the process of how we actually introduce new concept in our system. Next slide, please, Ruth. Exactly. So let's say that we don't have a concept. Let's say that we're reading a piece of text that is about a neologism, or it's about something that is that we, as Yewno, we don't have yet in our knowledge base, but we read a document that we see insertions of certain linguistical patterns. A typical example would be Brexit a couple of years ago, which is something that has not been defined in any textbook, but suddenly it started appearing in different publications. That's something that our system is hunting continuously for. So we are hunting for new concepts, and again, we're not going to go into the details of this process, which is pretty intricate, but as a general description, we hunt for syntactically and semantically coherent units that we can extract from a text that are, let's say, patterns that are recurring in certain documents, and we then try to categorize them and describe them as every other concept in our system. And if we are successful in doing so, we'll be adding that new concept into our knowledge base, and that concept will become a first-class citizen of our Yewno knowledge graph, and it will be able to then to appear in your searches. We will connect that concept with other related concepts, and so on and so forth. So this is how our technology then add new concepts into our knowledge graph. The next slide, Ruth, please, explains a little bit more in details what are the advantages of this approach, which we already, if you wish, anticipated, but it's really worth at this point stressing that out again. So if we look at keywords specifically, we're going to have the problem of polysemy, which is how it's technically called. So every single word or every single phrase might have a number of different meanings. Jaguar, Java, bank, Apple. So these are all very difficult words for any keyword-based search engine. On the other hand, a single idea can be expressed using many different words, many different syntactical patterns. So, for example, a single concept can be referred to by using different words, and we're dealing here with synonymy. So we can use different ways to refer to the same idea. So our approach deals with both of these problems at the same time. And we do this by of course, we start from the text as something that we observe, that the machine can read, that the machine can observe. But then from this text, we hierarchically build our internal computational structures that culminate into what we call a semantic space. And if we look at the semantic space in the next slide, it's pretty much a metric space for those of you that are more mathematically inclined. So it's a metric space where we can project every single concept, and the projection that we call embedding, this projection actually keeps semantic properties of the concepts that are being projected into this space. So how is this possible? This is possible through carefully created neural networks, deep neural networks that scan millions and millions of documents and understand how certain concepts are appearing in certain contexts. So we would need to go deeper in mathematical terms to understand how this projection works. But in a nutshell, what happens through this projection is that we turn something that is abstract, like a concept that is just a piece of text, as we said at the very beginning, which is the definition of a concept, into a vector in this semantic space. And the vectors that we create have a very nice property that's semantically similar vectors are usually topologically close in this resulting semantic space. So, for example, Apple intended as a company and Microsoft would be close in the semantic space, and they collectively and together will be close also to Java, which is a very famous programming language. But on the other side, we would have Apple intended as fruit, and Apple intended as fruit would be closer to pear or other fruits than to Apple intended as company. So this is how we differentiate those objects or concepts, even if they have the same name for us humans. The machine, as the human brain would, will create different representations for these concepts and will be able to separate them and disambiguate them depending on the context they appear in. The same goes then with Java, which again, Java is an island, but it can be a programming language. So I think at this point it's pretty clear what is the goal here. Really to create those semantic projections in a way that we achieve two goals. First of all, we go away from text and textual representation, but we translate a very difficult problem of text analysis into a metric space where we can then adopt all the techniques from algebra, machine learning, all the advanced techniques for actually then dealing with this metric spaces. And on the other hand, we achieve this goal of bringing together semantically similar concepts closer topologically in this semantic space. And then the rest of our technology is pretty much built on top of this internal representation. Of course, there are many other details rotating around how we really build this semantic space, how we really ensure that these concepts are actually, that semantically similar concepts are indeed topologically close in this space. But if we, let's say, embrace this vision, you can see how then you can really use this technology for indexing semantically your documents instead of indexing them in a traditional keyword-based search. So if I'm now able to index any single document by using concepts, which means that as my technology, as my AI reads and goes through the document, it identifies those concepts and index them not by their term that appears there, but by their real meaning intended as a pointer to a concept, then in a semantic-based search engine, you can then look for all of the documents in your big corpus in your library that have a specific concept. So as we the example that we did at the very beginning, give me all the books that have some reference to jaguars in your library, instead of giving you all the possible jaguars which are not in the context that I'm interested in, for example, the animals, with our technology, I will be able to give you only the documents having that intended concept. So this will, on one side, of course, make your life easier as a user or as a librarian. It makes your life easier in how to catalog different items. But on the other side, it also gives us the possibility to adopt more advanced technologies and techniques, and we can then relate different documents because similar concepts appear in them, they have similar topics, and so on and so forth. So this last slide here really puts everything together. I think we, at this point, really we covered most of the items here, but just to reinforce this idea that really every single concept will be projected, and you can see on the right hand of the slide, you can see a real vectors coming out from our AI, which is a combination, as we said at the beginning, of more a deep learning approach and statistical machine learning approach, and you will see how different concepts really emerge and how they populate different regions of our semantic space. And this is the basis of our technology, and this is the basis, I would say, of how we can use AI in the search. The next slide, I think, is more of a, and it closes my part of this talk, and of course we can go, we can discuss in details during our Q&A session. The last slide is more of a positioning this specific AI within the bigger movement of AI that is having, I would say, its renaissance in the past few years. And I borrowed these images here from different other presentations. They are not mine, but the message here is that we're still, as researchers, as practitioners, we're still working in what is called artificial narrow intelligence. So our artificial intelligence is still an AI that is more task-oriented. So in our world, the task was to semantically represent and index knowledge from a huge data sets, and we built a specific AI for doing this. Of course, building this AI requires a lot of trial and error. It requires a very specific knowledge. It required several years for us to build it at the stage where we're today. But we're still far from what is called artificial general intelligence, which is, I think, when people think of AI, they all think about this type of AI, which is something that is mostly promoted through media, where the artificial general intelligence is really a way to mimic how human intelligence work, but not in a task-oriented way, but in a more holistic way. So that an AGI would be building, which is the acronym for artificial general intelligence, would be building an agent, would be building then this intelligence agent that can really learn and adapt to any specific situation. So this closes my portion of the task, and I will then hand over to Ruth so she can show you how these ideas actually are turned into practice. Thank you.
Thanks, Haris. So going back to applications for scholarly research, so we see a number of things where AI can actually help students. And I've got a few case studies here of some of the ways in which artificial intelligence can help different types of researcher and different types of research. So one is really around more of an undergraduate student and developing research skills. So many students, when they start their university degree course, maybe starting new topics that they're not particularly familiar with, and they may have difficulty potentially formulating the best search terms, and they might not necessarily know the best place to go in terms of where they will get the best results. So one of the things that's useful about this kind of technology is the ability to visualize. So many people are visual learners, and being able to use a tool that helps them to visualize not only the search term they put in, but also related terms, can give them ideas in terms of what is connected that they would not otherwise have known about. And also can help people to drill down and find something that they're interested in. And it can help people to shape good research questions and introduce them to scholarly resources that they might not otherwise have found. Another use case we see is interdisciplinary research. So in our platform, we actually see about 51% of searches are interdisciplinary. By that, I mean somebody starts off in science and ends up in history, or somebody starts off in mathematics and they end up in biology. So somebody ends up in a completely different topic domain from where they started. So in terms of knowing what you're interested in, if you are a brilliant engineer and you go to a brilliant engineering database, you will undoubtedly find amazing, high quality information. You might not find any great new discoveries. Whereas if you can create an interdisciplinary environment, it's quite likely that great discovery will come from the intersection of fields. So that enables people to find things that they would never have thought to look for and wouldn't come across in a traditional environment. So AI, because it can enable this enormous multidimensional graph, can create those intersections and help people find things that they are less likely to find in a more traditional list of results. And it can also suggest to people non-obvious connections. The third use case we see is serendipitous discovery. So one of my friends who's a librarian said to me that he found the book that he wrote his undergraduate dissertation on next to the book he was looking for in the library. And I myself have found all kinds of interesting information walking around libraries and bookshops in a very serendipitous manner. And whilst digitization and the internet has been amazing in terms of opening up the world and helping people find these huge volumes of information, sometimes because of the precision of the query, you might get a list of millions of things that are all about what you looked for, but you definitely won't find anything that wasn't one of your search terms. So AI can also bring back a little bit of serendipity because it can start suggesting things that are related that you might not have known to search for in the first place. And it can enable people to hypothesize. So whether you're a high schooler or an undergraduate or a very senior, serious researcher, you might have an intuition, a hypothesis, and you can use an AI type environment to put in different concepts and to see if indeed there is a link between those things. So one of the other things I wanted to address, because I'm often asked, is really about bias and AI. So I can't comment on all of the AI out there, but I can comment on the bit that I'm familiar with in terms of our own environment. So it's not necessarily the case that it would introduce bias. In fact, not at all so. So to explain in a scholarly research environment how it would work. So I'm going to take a controversial subject here, the MMR vaccine and autism. So there are two very different schools of thought. One believes that there is absolutely no link between the measles, mumps, and rubella vaccine and autism, and one that believes that there is a strong link. And both of those two parties are highly educated, highly sophisticated people. So what does a machine do when it reads a lot of scholarly publications and it finds that there are two completely different opinions? So in this case, because it's a research environment, it's not providing an answer. What it will do is it will show the bigger picture. It will show you that there is a link between autism and MMR. It will also show you that there are controversies in autism. And it is for the researcher to decide how far they want to investigate and delve into all of those concepts and all of the documents supporting those concepts. And they need to read through them, and then they need to come to their own conclusion. So there are environments that do provide answers. This particular research environment is not doing that. So the responsibility is still for the researcher to read the relevant literature and to make their own decisions. But the point is that in this very visual environment, it's enabling people to see that context and that perspective around the subject that they're looking at. So the other thing that I think is really important in terms of the research environment is understanding your own research environment, your own community, who you are working with and who you can connect with, and the bigger picture. So for example, if you're considering an application for higher level research, you might want to understand what research your institution has already published on that. So again, in an AI environment, you can compare a small data set, potentially an internal repository, something like that, with a much larger data set of all published literature. And you can visualize the work of your community in a larger graph, and so you can understand how your research influences what's going on, and you can find the people you're looking for in your own community if you want to go and talk to them and connect people within the community, but people wouldn't necessarily know. So you might know somebody by their title, by their kind of high-level research attributes, but you might not know some of the detailed work that they had produced. The other thing that's very interesting from a research environment and that AI can enable is to really understand your collections, not just by the number of items, but also by the topics that they cover and the concepts that they're about. So having read the full text of any item of content, if an AI system can do that, it can give you a much more accurate picture of what's in your collections. And another really interesting and important thing for research is really understanding trends. So again, if a machine has read the full text of any item, whether it's a dissertation, whether it's a journal article, or whether it's a book, it can then tell you over time about what's been published in your collection on those topics. And you can understand, how things have changed over time, and you can also consider how you might want to add things into your collections or influence the work that you produce. So wrapping up and going back to the bigger picture around artificial intelligence. So we saw at the beginning that, as predicted by Davos, it will be a huge driver for change in the next 20 years. And just to give some statistics. So in 1965, the average term of an S&P 500 company was 33 years. By 1990, this has dropped to 20 years, and we expect it to shrink by about 50% in the next 10 years. So although these are general industry statistics, they're not specifically related to libraries and publishing, they will give us that sense, that trend, that directional view of where things are going. So things are beginning to change at a much, much faster pace. When you look at AI in the media, you often see sort of robots, self-driving cars, and all kinds of things like that. And indeed, AI does cover those things. But it also covers a lot of other things that we maybe are less aware of. So we asked at the beginning how many people are using AI either professionally or personally. And the response rates were actually quite low. But if you look at what you see in front of you, probably most of us are using some of these products. And so AI has been in our lives for a much longer time than we're maybe aware of. And then really looking at the market and challenges and where things are going. So traditional search environments, where if you go to a search bar and you know the right keywords and you go to a relevant tool and you put in a good search, you'll get a great result. They're worth about $1 trillion, or that's what they were worth in 2016. So if you think about what we've talked about today, if you think about an artificial intelligence-based system that can understand context and meaning, and therefore can give people so much more relevance than platforms today, the source from Davos predicts that by 2026, next generation search will be worth about 10 trillion, so 10 times the market that we see today. So there's huge change, huge growth, and huge opportunity in this space, and I really think it can change the pace of research. So I'm going to hand back to Matthew and Leah and open up for questions and answers. Thank you very much.
Thanks very much, Ruth and Haris. I have a question here in the chat. It is this. In your introduction, this is from Ken Chad. In your introduction, you mentioned how you apply your tools to unstructured data. Some abstracting and indexing providers see value in their historic efforts around structured metadata for especially journal articles. They see it as giving them competitive advantage against simply running AI technologies against unstructured full text for their AI offerings. What do you think? Would this approach enhance your offer, and are you talking to such providers?
Well, that's a great question. Thank you very much, Ken. So in terms of how our technology works, we have to understand context. So if you give me a list of words, and maybe that includes Java, and maybe that includes Jaguar, and I give that to a machine, they can't tell me whether that's Java, the programming language, Java, the island of Indonesia, or Java, the coffee. So from our perspective, our technology, in order to disambiguate, needs to have read the context of that item. So I think in terms of what you're suggesting here, could you use the existing traditional metadata where you might simply have a list of keywords or terms? So I think there is some opportunity where you could use that if those terms were fully disambiguated. So for example, if it was something like benzodiazepine, yes. If it was something that might have multiple meanings like Jaguar or Java, then no. So yes, I think there is an angle where there could be a blend, but it would be two things operating differently, and then you would have to apply disambiguation, if that makes sense. But let me know if that answers your question.
Can I just, if I can add on top of this, Ruth, that's actually a very good question. I think, Ruth, you answer most of it. I just wanted to stress that we actually do use a lot of metadata that we receive from publishers. So we do, as part of our ingestion effort, as we call them, we do ingest most of the metadata that we receive, and we normalize it using our internal standards, and we actually adopt mods as our internal metadata representation schema. So definitely, as you saw in the very last slide, we could see for every single document, we could see the authors, we could see the DOI, we could see other metadata items like ISSN for journal articles that you have been specifically asking for. But of course, we can also, as Ruth is saying, we could include specific other items of knowledge like keywords, as we were saying, but these need to go through a special disambiguation phase that we discussed in our text. So definitely, I think most of the metadata we're already including, but there are some items that cannot be easily mapped to our current schema unless we run it through our disambiguation.
Okay, and here's another question from Dawn. She said, I have a similar question. Let's think of mesh headings and mtree. Isn't there value in these headings? Why does AI need to reinvent the wheel? Isn't this valid taxonomy to integrate into their algorithm?
Absolutely, absolutely. We do use mesh. Many of our concepts are actually coming from mesh pertaining medical field and specific. So it's not really about reinventing the wheel here, Dawn. It's really about using that taxonomy in a more advanced way. So let's say that you have mesh and you have your taxonomy and you are looking for whatever medical term you're interested in, something extremely complicated. How can you, this is giving you just one part of the picture. This is giving you the existence of these concepts. And we actually do use mesh to bootstrap our technology with concepts from the medical domain. We're not reinventing the wheel here, but what AI will help you with is, now that you have all these concepts from mesh or whatever other provider, how can you really find them in your documents? How can you find documents that are talking about these specific concepts, and how can you do this in an interdisciplinary way? Of course, you can use PubMed, and PubMed will give you some certain indexing capabilities around these mesh terms, but again, these are not disambiguated. If we're talking about biodiazepine, yes, probably we'll hit the right answer, but if we're talking about other more complicated and more intricate terms, you might not. And then you cannot do this in an interdisciplinary way, because here, remember, our goal is really to cover all of your holdings and extract concepts from these holdings, aggregate them in our knowledge graph, and give you back the results. So I think this is where the advantages really come into play.
Okay, thanks again. And I have another question from John Hubbard. It says, thank you for your talk. Having software learn about concepts by ingesting historical discourse, which is filled with disproven theories and prejudiced thinking, seems to me dangerous. There's already been demonstrated bias in predictive policing, medical diagnoses, and even scholarly search engines, such as, or see the recent book, Masked by Trust, Bias in Library Discovery. For example, I don't see how not providing an answer regarding a retracted vaccine study with no supporting evidence is a good thing. Are you working on anything to eliminate misinformation rather than propagating it?
So I'll talk a little bit about how we select the content that we include, and then I'll hand back to Haris on this one. So I think from our perspective, this is a machine learning environment. So we do not censor information, and we do not manually curate information. We only ingest what we believe are high quality sources. So from that perspective, if somebody gives us a source of information, for example, a journal publisher, if an article is retracted, we will remove it within 36 hours. We don't take a reputable publisher and then censor that information further. And actually that's quite important in terms of our approach. Haris, I'll hand back to you for the other part.
Yeah, absolutely. Using high quality sources is one part of the definitely of the solution to this problem. On the other hand, remember, our technology is not here to give you ultimate answers. So our technology is not meant to replace a human being making any decision. Our technology will help you make the decision. And if you're a scholar or if you're researching about autism and you insert that search query in our semantic search engine, you will come up with a number of related concepts autism, and one of these will be controversies and vaccines and autism. So as a scholar, you will be able to surface that problem. You will be able to go back to documents explaining these controversies on a positive or on a negative side, but we leave the judgment to a human researcher and scholar about that specific topic. And this goes for autism, but it goes for many other fields that we might not have a definite, or common understanding of. So I think the technology here is not really to give you these answers about what is true, what is false, but it's about supporting you as a human in getting those answers yourself. And this actually will be supported, I have to disagree on this will be supported by the actual literature about those specific facts. And the misinformation, the fact that we're not propagating misinformation comes from the fact that we're ingesting only high quality sources that are curated. We're not here ingesting the web, or we're not ingesting other types of information that are not peer reviewed or human or curated beforehand. I hope this answers this question.
Okay. From an anonymous attendee, what positive and negative effects will AI have on the transformation of the profession of librarianship?
Ruth, I think you can answer.
So I think AI can really help librarians. Obviously, there's a huge different range of different librarian roles. And some people in libraries are really looking at things like preservation. Some people are looking at supporting users. There's this huge range of different things that you might be doing. But if you think about the fantastic resources that many libraries will have, and librarians themselves have this amazing training, but when somebody walks into your library, whether they're a 15-year-old high schooler, whether they're an 18-year-old undergraduate, they don't have that level of knowledge about librarianship. They don't understand necessarily everything that you have in your library to offer. And I think any kind of AI-based environment where the full text of the items has been read algorithmically by some kind of machine will help them uncover bits of the library resources that were previously hidden. So I think it will be of huge value in terms of opening up the existing resources that any library has to offer and helping patrons and the community really find what they're looking for. And I think on the other side of it, in terms of things like researcher services, the opportunity to help researchers understand what's there in the first instance, and also when they're doing things like writing the beginning of a paper, being able to get that semantically analyzed, which we see happening, is very exciting. So I think there's a lot of ways in which it can help librarians in the different roles that they play within their communities. Okay, and I have another question from Sheila.
what is the breakdown of disciplines covered in Yewno? My perception is that it is heavily biomedical. Yes, heavily biomedical.
Okay, let me explain how our topic hierarchy works. We have 33 topics, 800 subtopics, and over 5 million concepts. So there is, Sheila, there is a biomedical product, which is, as you suspect, biomedical, but actually we have an interdisciplinary product, which is very balanced across all subject areas. So it's deliberately got very, very broad coverage. So I'm very happy if, Matthew, if anybody would like us to send the topic hierarchy, I'm very happy to send that to you to share with people after the call.
Okay. Would you say, Ruth, that it is typical of companies that deal with biomedical or with artificial intelligence in search that they are heavily biomedical or heavily science-based?
So it's an interesting question. I think when we think about other AI companies, obviously in the past, 5 to 10 years, there's been an ever increasing level of investment in artificial intelligence startups like ourselves. And there are many, many people in this environment who focus on one domain. So there are many AI startups that focus only on finance or only on science, for example. And it was very important to us at Yewno that we actually could make sure that our technology could read all the different types of information, whether it's a news article, whether it's economics, whether it's science, whether it's humanities. And so way back in 2015, when we were doing our original kind of training and ingesting, we've always made sure that we had some very broad sources. And so I do think it's true of many companies. It's not true of us, and it's not true of everybody. But it is something that if a company wants to offer an interdisciplinary product, they need to train their algorithms across all the different types of content.
Great, thank you. Haris, did you want to add something?
No. I think that's
Okay.
all.
Okay, good. Well, I think then that we have no more questions. I don't know, Leah, would you like to finish? Or?
Yes, thank you very much to Matthew, to Ruth, Haris, and Jason for being here for a wonderful presentation, and to all of our attendees for being here, asking good questions. I wanted to let everyone know that the session is being recorded and the video and slides will be made available on the Charleston Conference website. Within a couple of days, we'll email everyone who registered for the session to let you know when those are available. Also, after the session ends, it'll redirect you to a very brief 3-question survey just to let us know how the session went today, and if you have suggestions for future speakers or topics, we'd love to hear from you. Let us know how we're doing. And with that, if there are no further questions, Ruth, Haris, Jason, anything else to add before we close?
Thank you.
Thank you very much.
Yes, thanks everyone, and we'll see you at the next Charleston Conference webinar. Have a great day, everyone. Bye.